So today we're going to talk about a sphere. A sphere is really just made up of circles. If you slice the sphere or get a cross section at any, and there's no base here, so anywhere, diagonal, vertical, horizontal, you're going to get a circle. The formula for the volume of a sphere is right on your reference sheet. It's 4/3 pi r cubed. Make sure you're cubing the radius. All right, so in terms of pi, okay, the radius is 6. I'm going to type in 6 for the radius. And when you type in the calculator, do not type the pi. So 4 divided by 3 times 6 cubed, which you just type the, press the caret button, you get 288 pi. Okay, let's skip number 2 and just go right to number 3. A sphere has a circumference of 38 inches at its widest measure. State the volume of the sphere to the nearest cubic inch. All right, well, it wants the volume, 4/3 pi r cubed. We don't have the radius right now, but if it gives us the circumference at its widest measure. So going back to number 1, the circumference is the outside of a circle. This is the circumference at the widest measure. Okay, if I make a circle anywhere else up towards the top or the bottom, it's not going to be as big as this. So it's saying that what I just traced is the 38 inches. Well, the circumference formula is right on your reference sheet. So off to the side here, let's write the formula. There's 2 of them, but if we're solving for the radius, let's use the one that's 2 pi r. Their circumference is 38. Bring down the 2 pi r. We're solving for the radius, and the opposite of multiplication is division, so we're going to divide both sides by 2 pi. Now when you put this in the calculator, you have to make sure that you put in parentheses in the bottom. Otherwise, the calculator is only going to divide by the 2. So let me type this in. And we get a long decimal, of course, right? But it's going to be, where's my cursor? Oh my gosh, I lost it. Okay. Sometimes this thing freezes and then I have to go start over again, but that was not the case. All right, 6.04, I'm not going to fit this. 788, come on. 7837. There's the radius. Now go back because it asked for the volume, so just type that in for r. And remember, again, it's cubed, okay? So it says the nearest cubic inch, which means I'm putting this whole thing into the calculator. All of it, including the pi. Let me kind of... All right, so I'm putting everything in. So 4/3 times the pi times... I'm doing second negative because I have that answer in my calculator still, that 6 number, and then just raise it to the 3rd power. Nearest cubic inch comes out to be 927, it would round to, cubic inches. All right, let's go to number 5. We have to do some problems where you work backwards. These are pretty important here. What is the radius of a sphere whose volume is 33.51 cubic centimeters, round to the nearest centimeter? All right, well, everything's in centimeters. We're fine. It gives us the volume, which is the V. So I'm putting 33.51 under the V. We'll copy everything else down. At this point, I like to get rid of the fraction. To get rid of a fraction, I multiply by the reciprocal. So I'm going to multiply both sides by 3/4. Now on the left-hand side, I have to actually put this into the calculator. Remember, at no point should you be rounding anything. So this will turn into decimals. We have to keep copying over. So I got 25.1325 on the left. And on the right side, the 4/3 times 3/4 cancel, so I'm just left with pi r cubed. All right, before we can find the radius, we have to get rid of that pi. So let's divide both sides by pi. Again, type that into the calculator. Don't round, and we're going to have a pretty long number here, which is 7. There's 4 9s, 23215 equals r to the 3rd power. Now, how do we get just r? Well, think about it. If it was r squared, we'd take the square root, but it's r cubed. You take the cubed root. You put a little 3 in there where the radical is. Cubed root. And I know I'm not showing you the calculator, but follow with me. To do the cubed root in the calculator, okay, you press the math button. And you're going to see the cubed root. It's option 4. So press math. You'll see it. It's option 4. Select that. And then you type in that long decimal that we had, the 7.99 number. And then when rounding to the nearest centimeter, it comes out to be 2. Just so you know, what does the cubed root mean? 7.999 rounds to 8, really, right? So the cubed root of 8 means What number times itself again gives you 8? Well, it's 2. 2 times 2 times 2 gives you 8. So that's why that answer makes sense. Now let's do another one here. This one, it says the radius of a sphere whose volume is, let me write the formula. Let me write the formula first. 4/3 pi r cubed. The volume is 31,356.7 pi inches cubed. So when you write the V, you have to write the pi. Do it. You have to write it. If you don't write it, you're going to get the wrong answer, but also something nice is going to happen right here. Instead of worrying about the fraction, look, both sides have pi. Divide by pi, and already this is going to be a little bit nicer of an answer here because, or process, because we don't have to deal with the pi, which is an irrational number and goes on forever. So if you can, divide by pi first to get rid of it. Okay, now I want to get rid of that fraction. Just to multiply by the reciprocal like I did on number 5 there. So multiply by 3/4, you just flip it. Let me type that in. 3 divided by 4 times 31,356.7. Okay. I got 23,517.525. Now on the right side, remember 4/3 times 3/4 is 1, so it cancels. And at this point, once you have r cubed by itself, isolated, you can take the cubed root. You have to write that 3. If you don't write the 3, it looks like you're doing square root. So again, you know, if you don't have a calculator, just make sure you practice this back when you come into class, in case it's on the test. Hint, hint. Press the math button. It's option 4, and then just type in that 23,000 number. And to the nearest tenth of an inch, I'm getting 28.7. That is the radius. Okay, next couple are basically the same thing, so let's skip it. And actually, I'm going to have to stop this and pull up the next page. All right, let's try number 9. What percent of the entire solid to the nearest percent is made up of the hemisphere? So what we're going to have to do is find the volume of the hemisphere and then the volume of the cylinder. A hemisphere is just half a sphere, so all I'm doing is putting 1/2 in front of the formula for a sphere. The radius of the hemisphere is 3, so I'm going to type in 3 for r. And sometimes you can try in terms of pi here, just to see if you don't have to deal with copying a long decimal throughout the entire problem. So let me try that out. I'm not typing the pi right now. Yeah, that's pretty nice. It only gives us 18. So it would be 18 pi for the volume of the hemisphere. Okay, now we also have to find the volume of the cylinder. So it's pi r squared h. The radius is 3, and the height is 7. And we'll do this in terms of pi again. It's going to be nice. Watch. 3 squared is 9 times 7 is 63. So we have 63 pi. And the question said to find the percent. The percent formula is part over whole. Let's do the whole. The whole is everything, right? So for the whole, I would have to add the cylinder and the hemisphere. So if I add 18 pi and 63 pi, I'm really just combining like terms. So when you add those, you'll get 81 pi. That's the volume of everything. So that's the whole. For the part, you have to go back to the question. It says, what percent is made up of the hemisphere? So the hemisphere has to go on top. That was the 18 pi. Before we put this in the calculator, I just cancel the pi's out here, and then you don't have to deal with it. Type in 18 divided by 81. It comes out to be, I'll show you a little bit of it. It's 0.2 repeating, but we need it to be a percent, so move the decimal over 2 places, and the question said rounded to the nearest percent, so it's 22%. Okay, let's skip to number 11. 3 tennis balls are sold in a cylinder. The balls have a 3-inch diameter. So let me draw that in. So here's the center. Okay, here is the diameter, and that's going to be 3. If the cylindrical container is made just large enough to hold 3 balls, what percent of the container is empty? Round to the nearest percent. Well, no matter what, we're going to have to find the volume of the cylinder and then the volume of the 3 spheres. Okay, so let's do the cylinder first. So the formula is pi r squared h. Remember, all these formulas are just right from your reference sheet. The radius, well, it said the diameter was 3, so that makes the radius 1.5 squared. What's the height of the cylinder? Think of the diameter as 3. Just go the other way. Watch. 3. Here's another diameter. That's 3. Sorry, I'm not exactly through the center. It's hard to do perfect. And then another 3. So 3, 6, 9. The height is 9. So you just have to think of the diameter going vertical through each of the spheres. Okay, so the height of the cylinder is 9. Try it out in terms of pi. Why did I put a V there? Oh, man. Okay, I gotta fix this. See, I'm in an area where the toolbar is not there. And that's a pi, guys. That definitely looks like a pi. All right, I'm trying this in terms of pi. I just put in the 1.5 squared times 9. I got 20.25. And we have the pi. See, I can't go back now. I'm already like almost 4 minutes in. Gotta keep going. Even though that pi there bothers me. Gotta keep going. All right, what else do we have to find the volume of? We have 3 spheres. What do I do with a 3? Easy. You take the volume of the sphere formula and you put a 3 in front. Multiply by 3, right? 3 spheres. So times 4/3 pi r cubed. The radius of the sphere is, again, I told you the diameter is 3, so if you divide it in half, the radius is 1.5. All right, we'll try this in terms of pi as well. So 3 times 4/3 times 1.5 cubed. I just did not type in the pi, and I got 13.5 pi. All right, what's the percent? Part over whole again. Same thing as before. To get the whole, not the same thing as before. I lied. Not the same thing. Not the same thing. The whole thing is the cylinder, right? You don't have to add the spheres to it. They're already inside. The sphere's volume is already included within the cylinder. So the whole is 20.25 pi. I just made like 4 videos in a row, so I'm losing steam here. Okay, what's the what's the part? I think after this I have to take a break. The part is whatever the question asks for. If you go back, it says, what percentage is empty? Well, how do I get the empty space, that volume? Subtract out the spheres, right? The empty space, I'll kind of color it in. Like this is the empty space, right? All of this. So I don't want the spheres. So if you take the cylinder, here, I'll kind of show you off to the side. If you take the cylinder volume and you subtract out the volume of the 3 spheres like this, they're like terms. They both have a pi. Think of it as x's. You would get 6.75 pi. So that's the volume. That's the part. That's the volume of the empty space. Just like in number 10 or whatever, number 9, the problem we did before, I'm going to cancel the pi's out and just type in 6.75 divided by 20.25. I get 0.3333, 0.3 repeating, right? To the nearest percent, it says. Okay, so move the decimal 2 to the right. It's going to round to 33%.